In this video, let's introduce about what we mean by the finite integral. Alright, so let's say we have defined integral. Let's say if we have this is indefinite. Let's say if you integrate gx dx, this is we name as indefinite. Alright, indefinite. So where there are no limits, so there are no lower limits and upper limits. Alright, so this is called as indefinite integral. So definite integral is defined by a limits, which is a lower limits and a upper limits from a to b. We integrate gx, we integrate this integrand, alright, with respect to x from a to b, the lower limits and the upper limits. So for example, if I differentiate fx, and I getting gx, for example, if I differentiate fx, I getting a function gx. So as you know that integrate is a reverse process, right? It's an anti-derivative, alright? So means that if you integrate this, you will get back your function fx, right? So which is defined as fx. Once you integrate, you get fx from a to b, because when you differentiate fx, you're getting gx. So you integrate gx, because that you know that there is a lower limit and upper limits, so you will get the fx, alright, the function fx, so which is also named as the antiderivative of this function here, alright. So then in a to b. So we define finite integral in this way. So we take the upper limits, the value of the upper limits for fx minus the lower limits. Alright, this is the way we define the finite integral. So next, we move on to as you know that this is the definition of the finite integral. So now we're going to move on to explain about the properties of the finite integral. Alright, let's go one by one, the properties of the finite integral. Alright, the first properties will be, let's say if I integrate a function from a to a, right? A to a means that the lower limit and the upper limit are the same. It's actually is a straight line, alright? Let's say you have a curve, then as there is a value a here. So if you integrate from a to a means that you are integrate with a line, right? There is no area for a line. So usually we will define this one to be, let's say integrate a to a dx. So the value will be 0, right? This is the first property. When the value are the same, the lower limits and the upper limits are the same. And the second property here will be, let's say if I integrate a to b, and where there is a scalar, there is a product of a constant k for the fx. So if this k is a constant, so we can bring it out, because this is a constant, it's not changed with respect to x. So I can just factorize the k out, right, before I integrate. So this is also another properties. Alright, so this is the second properties. So let's move on with the third properties. So there are some properties that you must know, alright, very important. For example, if I have a to b, right, for a function. So what happens if I interchange the limit? Means the lower become upper and the upper become lower. So means so a to b, now is b to a. So what happens when you're doing this? So of course they are not the same. They are not the same because the difference is if we add by a negative. Alright, we add by a negative here. So means that these two will add up to 0. If you add up these two, you will get a 0. Alright, so means that a to b is equals to negative b to a. Alright, and the fourth properties will be, so if you integrate a function a to b for a combination, means that by addition or subtraction of another function with respect to x, so we can actually rewrite this as a to b fx dx plus minus integrate from For the same thing, a to b for gx dx, right? We can write this in the form of summation and addition, but with two separate integral. Alright, and lastly that you need to know will be, alright, let's say b is between a value between a and c, right? Between a and c, and make sure that fx is differentiable. Alright, is differentiable from a to c, right? It's differentiable between a and c. Alright, let's say it's between a and c, so it's differentiable. So it means that if, let's say, you have integrate from a to c for fx dx, we can rewrite this to be integrate from a to b first, right? You know that b is between the value of a and c, so you can just write fx dx, right? Plus with integrate from b to c, right? So it's from a, b, and c. So b is between a and c, so it's from a to b plus with b to c. So they are actually represent the same meaning. Alright? So but provided that x between the function at the time between a and c is differentiable and continuous. Alright, so this is the 5 properties that you must know. So later we go for the next video for the examples by using the properties of the finite integral.